Okay, so welcome back, everybody. I hope you had a good week. A couple more people coming in, so. All right, so at this point, if you want to, you can type your name into the chat for attendance, and so I'll have a record that you're here. Anything you typed before won't be there, so please check your name, type your name back into the chat. Okay, so yeah, and I'm gonna mute everybody. Okay, so welcome again to everyone. Hopefully some more people will come in as we go on. So we're continuing our study today of statistics and graphical presentation of data. And today is going to be about, one of the most useful methods for presenting data, which is called a histogram. So we're going to be speaking about histograms and classes and all of this kind of stuff today. Okay. So, but first, I want to just do a quick going over of the homework exercises. So welcome everybody. Welcome Christopher, Miata, BC, Ed. So, okay, so this first exercise, which doesn't really have a right answer, right? So suppose a survey is given where people are asked about the highest level of education that they've completed, a primary school, secondary school, university, or graduate school. And the question is, what do you think would be the most appropriate way to visually present the resulting data? There's a couple of reasonable answers, and I'm interested to hear, an argument for whichever your preferred answer is. So does somebody have an opinion on this? I'll say it's an opinion instead of an answer. Anybody want to venture a guess, even if you don't have even if you can't defend your opinion, if you just have one, if you just want to say what you think might be the best way to present, that'd be great. So does anybody have an idea? Yes, Christopher?
Or... Yeah. Mm-hmm. So I would say I could represent the resulting data in the form of a bar chart.
Okay, so we have
depend.
Mm-hmm. Oh, wait. Right. So we have so bar chart.
Mm-hmm. And I can look at it in a way that acting randomly, there will be a couple of people that will tell me maybe primary education, some will tell me secondary, and others will tell me university or graduate school. So we'll see that there will be some variation in number, and I will place that in a bar chart because there will be variation in number. So of course, those who will go the highest number, maybe say it was secondary education that got as the highest number, I could represent that as the highest, in the bar, the longest line for the bar. And others will say for primary education, the numbers too might differ from that of the secondary education. So preferably I could look at it from a bar chart or so.
Okay, that's a great answer, and it's a good justification.
Yeah,
all right. So, yes. Who else?
Yeah, Clinton.
Yeah, Clinton.
Yeah, thank you. I think for me, I think the best way I could represent the data would be using a pie chart, since we do not have too many items we are dealing with. So a pie chart would be preferred for me.
Okay, yeah, so that's good also. So the point is that there's no right answer to this. It could be a bar chart and it could be a pie chart. And it also depends on kind of what you want to get out of this data. So Clinton says a pie chart because there are not too many categories, right? And so, one question would be, are you more interested in comparing the categories to each other? Are you more interested in comparing the categories to each other or to the whole? Okay, so if you're more interested in comparing the categories to each other, then usually a bar chart is a better idea. Because a bar chart lets you really see the heights of these different bars. And it's much easier to compare the heights of two bars than it is to maybe compare the size of two wedges in a pie chart, right? Because, I mean, if two wedges in a pie chart are kind of close in size, then it's not always easy to see which is bigger or which is smaller. But in a bar chart, it's usually easier to see which bar is higher and which bar is lower. On the other hand, if you're really more interested in just understanding, you know, what percent of the entire whole of all the people, you really want to know what percent went to primary school. This is, you don't really care whether more people went to primary school or secondary school. You just really want to know like what percent went to primary school. Then that's sometimes easier to see in a pie chart. So if you're more interested in comparing it to the whole, then you can use a pie chart. Okay. But in this case, there's not really one right answer. I mean, either a bar chart or a pie chart is a reasonable way to present the resulting data, and they both have their own strengths depending on what you want. So both Christopher's and Clinton's justifications are good, and you know, you could use either one, and in a data report, you might see either one in real life. Okay, any questions on this? Okay, so just a reminder to everybody here, if you haven't yet put your name into the chat, to try to type your name into the chat, please. Okay. All right. Okay, so let's talk about homework exercise number 2. So this is a stem and leaf plot for the following data. We have all the different counties in Liberia, and this is a census from 2008. That got the population of all 15 counties. Okay, so we want to just kind of compare the counties to each other and see, you know, visualize this data somehow. And we're going to do it using a stem and leaf plot. And so the question is, we know that we're going to have a stem. Let me use blue. We know that we're going to have a stem, and we know that we're going to have some leaves. And the question is, what do you think we should, remember that the stem and the leaves, we have to have a consistent place value in between them. So what digit do we think should be the digit that defines the stem? So the digit on the left side of the bar, and what digit should be the first digit of the leaf, you know, on the right side of the bar? And probably we're only going to do, you know, one digit for the leaf, or maybe two, because getting this population down to like single digits is not really very accurate anyway. So does anybody have an idea, like for instance, for maybe for Bang County, where would we want to separate the stem from the leaves in a way that makes sense for this data here? And for this one, I think there really is kind of a right answer. That there is one answer that I think is better than all of the other ones.
Yeah.
Clinton? Yeah. Clinton?
Okay.
Or sorry,
So
who's speaking?
you.
Yeah, Clinton, yeah.
Yeah, so so in the process of choosing the leaf and that of the stem, but for this data to make it meaningful, we want to take the first 2 digits. Yeah, I want to take the first 2 digits, and then the remaining 3 will be for the leaf.
Okay, so this idea, okay, so the idea is first 2 digits for what? For Bang? First 2 digits?
The first two digits for the stem.
Okay, but so now remember, we can't just take the first 2 digits. We have to, because all of these data have different numbers of digits, right? Some counties have 5-digit numbers for their population. Some counties have 6-digit numbers. And one county, Montserrado, has 7 digits, right? So if we take the first 2 digits of each of them, then we're not being consistent with place value, right? So the stems, the first 2 digits of Bomi represent 82,000, whereas the first 2 digits of Montserrado represent 1,100,000. So we can't just take the first 2 digits for each county because those first 2 digits are representing different place values. So we have to be consistent about the place value. So the way you can think about it is you want to always have the same number of digits in the leaf, and then the stem is just whatever's left over. So where would you?
Yes,
where
can
would
I
you
come in quickly?
Yeah, sure, Ed. Yeah.
Yeah, okay. Because all the digits are not the same. What I look at, I decided to round or maybe probably to the nearest 1,000. I know what they are going to work.
Yeah, that's good. Nearest 1,000 is good.
Okay.
Yeah, so rounding to the nearest 1,000 is good. We could even round to the nearest. Yeah, I mean, rounding to the nearest 1,000 is good. That's probably the right thing.
Yeah, sure.
Yeah. So Prince, yeah. Prince, were you saying something? Or is your signal cut off?
Hello, getting me?
Hello, Prince. Yeah, I'm getting you now. I wasn't before.
Okay. After is only to the nearest 1,000 you can run it off to, or you can also choose for yourself maybe a place where you want to run it off to, like 100.
Yeah, there's no right answer there. I would say here rounding off to the nearest 1,000 is good because the extra digits are going to be just not so useful. Remember, we want to visualize the data. We want to see kind of like how many counties we have with different populations, and rounding to the nearest 1,000 probably isn't going to lose you anything, and it'll make the data cleaner. I might even round to the nearest 10,000 here. We'll see what happens with the stem and leaf plot. But in any case, the rounding is not the most important thing. The most important thing here is to figure out where we're going to choose the stem. Remember, this stem here represents a place value. So we're going to have some number of digits that go after the stem and some number of digits that go before. Some number of digits that are the leaf and some number of digits that are the stem. Okay. So I mean, so what I see here is I see a bunch of 5-digit populations and then a bunch of 6-digit populations, some of which start with a 1, and then you've got a 4 and a 2 and another 2 and another 1. And then a couple of very large counties. You have Nimba and Dorado, which are maybe bigger than all of the other ones, right? So what I would do, so here's one idea. If we choose only the last 4 digits as the leaf, so if we choose only the last 4 digits of the leaf, so I'm going to write this as a question mark because it's not actually what we're going to do. Then if we're looking at the first digit, at everything else before that, we're going to have, well, it looks like we have, I'm going to look at that. We've got a 6, and then we've got 2 6s, 2 8s. We got a 5. I'm just trying to get these in order. A 5, 2 6s, 2 8s. So if we choose last 4 digits as the leaf and we rounded to nearest 1,000, then what I would get for my stems, I would have, the 5. This is for Grand Cru with a 7 over here. For River Cess and River, is it River G or River G? Is it River G or River G? How's it pronounced?
It's River G.
River G, okay. So if it's River G, so I've got 6, this would round to 66,000, and this would round to 67,000. So I'd have a 6 with a 6 and a 7 over here. And then what else? I have Barpolu, which is going to be an 8 and a 3. So that would be 8 and a 3. And then and then I have Bomi, which is 82,000. So that would be an 8 and a 2 and an 8 and a 3. So why don't I put those? I'll put those in order. So 8 with 2 and 3. Now we get up into the 100,000. So here, what has 100,000? Here I've got a 10, right? So here I would have to do a 10, and then I'd have that rounds to 105,000 over here. So it'd be a 10 and a 5, right? Remember, I have 2 digits here in my leaf, in my stem, because the place value needs to be consistent. So if I'm dividing between the thousands place and the 10,000s place, if I'm doing that for all of these counties, then for every place in my data set, I need to make the same division. Okay, so over here, I still need to divide between this thousandths place and the 10,000ths place over here. So now what's next? I guess we've got Grand Cape Mount, which would be 129,000. Grand Geta is 126,000. Yeah, so that I would have a 12 over here, and then with a 6 and a 9, one for Cape Mount, one for Geta. Then moving up, I guess the next is Maryland, which is 136,000. So I'd have a 13 with a 6 here. And then I have, what's next? Margibi, I think. So Margibi is going to be, that's going to round right to 200,000 if I'm rounding to the nearest 1,000. So that's going to be a 20 and a 0. And then Lofa is going to be 270,000. So I'm going to have a 27 and a 0. And then Bong is going to be 329,000. So I'm going to have a 32 and a 9. Nimba is 468,000. So I have a 46 and an 8. And then last Montserrato is, remember, now I have to have 3 digits on the right over here, because I always have to draw it between the thousandths place and the 10,000ths place. And so I would have 1,145,000, but really that's going to be a 114 over here, and it's going to round to a 5 on this side. So we're going to have 114 and then 5. So this is a reason, and I think I got everything right. I didn't miss, oh, I missed Grand Bassa. Okay, oops, I missed Grand Bassa. So that's over here. So that's 225,000. So sorry, I have to add an extra, space. I have to add an extra 22 over here with an extra 5 over here. Okay, so this is a reasonable choice, but the problem with this choice is that visually it doesn't look like much, right? I mean, almost every category has one entry, right? Almost every category has one entry, and then a few have 2 entries, but the shape is almost kind of like a straight line, and it doesn't really give a good sense, at least visually, it doesn't give a good sense of where the populations are clustered. Okay, it doesn't give a good sense of where the populations are clustered. It just, I mean, if you read the numbers, then you can read things off. But I mean, you could have read it just from the population originally. You can see kind of how many tens of thousands each county has: 5, 6, 8, 10, 12, 13, 20, 22, 27, 32, 46. But just this shape over here is just not very insightful. It's not telling you very much about the clustering. So this is not wrong, but I would say this is not how I would choose my stem and my leaf. Okay. Does anybody have maybe a different place where it might make more sense to split the difference between your stem and your leaf? Here. Just in the interest of time, I'll say instead, I would choose the last 5 digits as the leaf. Okay, I would choose the last 5 digits of leaf as the leaf, because this is going to compress things into fewer categories with more variation between how many things are in what category. And I think that's going to be better data. So this over here is with 4 digits as leaf. So I'm going to do another table right here with 5 digits as leaf. So if I choose the last 5 digits as the leaf, and then maybe round to the nearest 10,000 instead of to the nearest 1,000. Right, so what happens? What does my plot look like if I do that? So if I choose the last 5 digits as the leaf, now what do I have? Well, I'm drawing now the lines over here. So I'm drawing my lines with 5 digits after the line. And now what do I have? Well, I have a whole bunch of 5-digit counties. So if I'm choosing 5 digits as the leaf, then what's my stem for Bomi and Gwarpolu and River Ses and River G and Grand Cru? Well, what's my stem for those if I'm choosing the last 5 digits as a leaf?
Yes.
Yes. Who's that, Armstrong?
Yeah.
Yep.
I think the stem would be 0.
Exactly, right. So the stem for all those is going to be 0. And so then
Yes.
what do I have? I have Bong is going to be an 8. Barpolu is an 8. River Ses is a 7, right? Because I round up with the 65. So 8, 8, 7. The 5 will be a 6. And the River G here will be a 7. So I have 6, 7, 7, 8, 8. So I'd have here 6, 7, 7, 8, 8 as my sorry, let me fix that. So I would have 6, 7, 7, 8, 8 as my leaves for the stem being 0. That's going to cover all of the 5-digit counties. Okay. Now I have the stem of 1, and that's going to get me Grand Gede and Maryland and Grand Cape Mount and Sino and I guess probably not Margibi because that's going to round up to 200,000 eventually. So here I have a 1, and I'm going to have here if I'm rounding to the nearest 10,000, then I'm going to have 130,000, 140,000, so 130, 140, and 100,000, and another 130,000. So it's going to be a 3, a 3, a 4, and a 0. So here I would have so 0, 3, 3, 4, if I want to write them in order. Now I have my next stem, which is going to be a 2. What do I have in the 200,000s? Well, Margibi rounds to exactly 200,000, and Bassa rounds to 220,000, and Lofa rounds to 270,000. So I have 2, 0, 2, 2, and 2, 7. So I'm going to get a 0, a 2, and a 7. Now in the 300,000s, I only have Bong, which rounds to 330,000. So 3 with just a 3. And then with what was I going to say? With Nimba, this rounds to 470,000. So I have a 4 and a 7. And then Montserrato rounds to 1,100,000. So now I would have an 11 over here. Sorry, 1,140,000. So I'd have an 11 here with a 4. Okay, so in my opinion, this stem and leaf plot is better than this stem and leaf plot. Okay, I think this one is better because you can really see the clusters a little bit more. You see that most things are clustering around 0 hundreds of thousands or 100,000 or 200,000. And then as you get past that, there's a few big counties that have a lot more than that. But most of the counties are down here in this range around 100,000, 200,000. Okay, so I feel like this chart, this plot over here gives more visual information than this one, where you choose the last 4 digits as the leaf. So in my opinion, I would go with 5 digits as the leaf. So I think this gives more information. Okay, so I would go there. And then I would say you wouldn't want to do 6 digits, because if you did 6 digits as your leaf, then basically everything would get compressed into one category except for Montserrato. Everything would be a 0 and Montserrato would be a 1. And that's maybe not so meaningful either. So I think this 5 digits is the sweet spot. It's the middle in between not compressing enough, which is what you do with 4 digits, and compressing too much, which is what would happen with 6 digits. Okay. All right, so any questions about this example? Sorry, this thing is okay. Sorry, my computer is running slowly. Something here. Okay. Okay. So all right. So let's move on today then. So all right. So we're going to be talking about histograms for the rest of today. So what we saw last time, remember, is that this numerical data can be shown in various different ways. We talked about stem and leaf plots last time. Today, we're going to talk about histograms and frequency tables. And then next time, we'll talk about cumulative frequency curves. And then a little bit later on, we'll talk about box and whisker plots. Okay. So what are frequency distributions in histograms? Well, a histogram is visually similar to a bar graph. Often, if you're not speaking carefully, you might call it a bar graph or a bar chart. But a histogram is used particularly when the data are numerical. Okay, remember last time we talked about categorical data, like what level of schooling somebody's completed. But if the data themselves are numerical, then we generally call this a histogram. Tony, any question? No. Okay. So histograms are very, very useful. They show up all the time. They work well whether or not the data set is large or small, and whether or not there are lots of different values. And there's lots of different ways to make them. So you can make the bars are not spaced in a histogram, although you can make them spaced if you want. You have often the bars in a histogram are right next to each other, but you can add a little bit of white space between the bars. That's not something that you can't do. So there's a few different ways of doing histograms. So if you have an internet connection, then you can use this website, which is very nice for making histograms. If you have a laptop with Microsoft Excel, but no internet connection, then you can make them in Microsoft Excel also. And it's also worth learning how to make them by hand. So we'll try to do, all three of these. We'll try to do all three of these today for different examples. Okay. So let's first do an easy example where we're going to make them by hand. Okay. All right. So to make a histogram, what do we need? We have to start with something that's called a frequency table for our data. So we saw this last time for categorical data, but you can do this for numerical data also. So a frequency table, what is it? It just has two columns and one listing each measurement, which I spelled wrong, measurement, and the other listing the number of times that measurement occurs in the data. And when we make the histogram, eventually when we draw it, we're going to need to choose a horizontal and a vertical scale. The vertical axis usually represents the frequency of the measurements, while the horizontal axis represents the different values of the data. Okay, so this will be more clear when we do our example. And when the data takes on very few values, you generally mark each value of the data, along the horizontal axis, equally spaced, and you make a column with each value at the center. And the height of the column is going to represent the number of times that the value occurs. So this is going to be a kind of simplest case. Hey, this is going to be the simplest case. And so we'll do one example on this case before we get to start to class intervals and continuous measurements and stuff like that. Okay, so this is going to be the simplest case. So here's a histogram example. So a bunch of raccoons were observed in Texas. They were observed for a summer for their mating behavior, and they observed a number of female raccoons. And these are the data for how many male raccoons each female raccoon mated with. So what we're going to do is we're going to make an absolute frequency table and a relative frequency table. And then with this, the data is simple enough that we're going to be able to construct the histogram by hand. So we'll do this one by hand, and then later we'll use computer programs to do it instead. And remember that what is the difference between absolute frequency and relative frequency? Well, the absolute frequency is just the number of times the measurement occurs, and the relative frequency is the percentage or the fraction of the whole that's represented by the number of occurrences. Okay? So in this case, if we're going to do our frequency table, what we're going to have is we're going to have some columns. So this first column is going to be number of partners. And then in this column, I'm going to have the absolute frequency. And in this column, I'll have the relative frequency. Okay, so here we see that our data, all that we have is 1, 2, 3, and 4, right? So it's going to be 1, 2, 3, and 4. So for the absolute frequency, we're just counting the number of ones. It's just the number of raccoons who were observed that were monogamous, that mated with one partner. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 ones over here. For the twos, how many twos? We have 1, 2, 3, 4, 5. So we have 5 over here. For the threes, we have 1, 2, 3. And for the fours, we have 1, 2, 3 as well. Okay. So this is our absolute frequency. So it seems like most raccoons are monogamous. We'll see a chart that shows that. So the relative frequency, we have to divide by the total number of measurements. So what's the total number of measurements? Well, we could either just count them all, or since we've already written this all down, we know that the total number of measurements, that this is going to be equal to 18 plus 5 plus 3 plus 4, and that's going to be equal to 30. Okay, so to get the relative frequency, we have to divide our absolute frequencies by 30. Okay, so you can do this with a calculator if you want. So for the absolute frequency is 18. The relative frequency here is going to be 0.60. I'll just round to 2 decimal places. I'll just do 2 decimal places. So the relative frequency is 0.60. 5 out of 30, that relative frequency is 0.17. 3 out of 30, that relative frequency is 0.10. And 4 out of 30, that relative frequency is 0.13. Okay, the measurement is 29. Did I make a mistake? 1, 2, 3, 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 24, 25, 26, 27, 28, 29. You're right, 29. So I must have counted the ones wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18. Did I count the twos wrong? 1, 2, 3, 4, 5. Threes, 1, 2, 3, and I'm getting very confused here. How many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It really seems like 18. Let me count one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.
Hello, sure.
26, 27, 28. Yeah. What did I do wrong?
The four is 3 and 4.
Oh, the 4 is 3, not 4. That's right. Thank you. Thank you. Okay, great. So that's a 3. Okay, so that means I'm going to have to change all of these relative frequencies. Okay, so 18 plus 5 plus 3 plus 3. Thank you for catching me. Equals 29. Okay, so let me just do the math. I can divide by 30 in my head, but I can't divide by 29 in my head. So 18 divided by 29 is going to be a relative frequency of 0.62. 5 divided by 29 is going to be a relative frequency of 0.17. And 3 divided by 29 is going to be a relative frequency of 0.10. And 3 divided by 29 is also going to be 0.10. And if we notice that the relative frequencies don't quite add up to 100%, here they add up only to 99%, that's because of a rounding error. And that's to be expected anytime you do rounding. Okay. But in any case, this is our histogram. And so now this is our frequency table. Okay. And so now from this frequency table, we can draw a histogram. And in this case, we're just going to draw bars with since we're using discrete measurements, we're just going to have the measurement in the middle of each bar. Okay. So let me add things. So how do we draw the histogram? I'll have a vertical axis and a horizontal axis, and then maybe I'll have, I'm going to mark 1 and 2 and 3 and 4. And then what I'm going to do, so maybe for the, so this is going to be, you know, frequency. So maybe I'll say absolute frequency histogram. And down here is going to be, I'm going to label my axes. So down here I have number of partners. And up here I have absolute frequency. And to figure out how we label the y-axis, well, we look at the range of our data. We've got 3, 3, 5, and 18. So we just want to choose accordingly so that the histogram can really show us the distance between the bottom and the top. So maybe I'll mark this in increments of 3. So I'll call this 3, 6, 9, 12, 15, and 18. So I can mark this in increments of 3. Let me just mark this over here. This is going to be 0. Let me draw this a little bit better. Okay. And so now what do we have? Well, for number 1, we know this is going all the way up to 18. So I'm going to draw a bar with 1 at the center, going all the way up to 18. Then for 2 partners, we had 5 was the frequency. So I'll draw a bar with 2 at the center, going only all the way up to 5. And then with 3 partners, it only goes up to 3. And with 4 partners, it also only goes up to 3. So these are supposed to be equal width. I didn't do a great job because I'm drawing it by hand on a screen, but maybe doing this makes them a little bit better. And maybe this 2 bar should be a little bit bigger also. Yeah, and if I want, I can fill them in. Maybe I'll just shade them instead of filling them in all the way. So I have 1, 2, and then 3, and then 4. Okay, so this is my histogram. And if you want, you can use different colors. Sometimes that's helpful. You can use different colors for different bars. Okay, so this is your basic histogram when you have discrete categories of data and the data is small enough that you can just count them. If you want to, you can sometimes write the label on top of every bar. This can help the visualization. So you can include that number if you want to. So you're just including the frequency for every bar. Or if you don't want to, you don't have to do that. Okay, but this is the kind of histogram that's relatively easy to draw by hand. All right, any questions on this?
Sounds great.
Okay, great. Other questions? Okay, so sometimes your data, a lot of times if you have an experiment, your data are not just going to take nice, neat, few discrete variables, right? A few discrete values, right? I mean, in this case, the data only took on the values 1, 2, 3, and 4. For lots of experiments, that's just completely unreasonable. It's not reasonable that your data will only take on some small number of discrete values. So usually you're going to have some sort of range. Okay, yeah, you can use different colors to distinguish the different variables if you want, or the different values. Yeah. So, right. So over here, if I wanted to, right, I could make, you know, one of these bars. I could make one of these bars green, and I could make another one of the bars, you know, purple. And I could make the last bar, I don't know, orange if I wanted to. Right, so that can be nice. That can also help your graph. Yeah. So yeah, and the big difference between a histogram and a bar graph is that the histogram has a numerical axis down here instead of just a bunch of categories. Right. That's the big difference. And usually also the histogram has the bars right next to each other because your numerical data is supposed to be evenly spaced. whereas for a bar graph, you just have categories, so it kind of doesn't really matter where you put them. It doesn't matter what order you put them in. For a histogram, your data needs to be in an increasing or decreasing order. I can't just put the 1 and then the 3 and then the 2 and then the 4, right? I have to have the categories, the numerical categories in order. Whereas for categorical data, I can just put them in whatever order I want. Okay, so, right. So now if data takes lots of values, it can be more convenient to build a frequency table where each row represents a range of variables across an interval instead of a particular value, because there might be just too many different values. And if you did a different line in your frequency table for every possible value, then your table would be too big and it wouldn't give you any useful information. So generally, so these ranges are sometimes called class intervals. You'll see them called that. And generally, you want to make each of the class intervals equal width. There are certain cases where the data may warrant making an exception to that. Although when you have exceptions to that, you have to be very careful about making your histogram. So maybe I'm not going to talk about that too much today, but as a good rule of thumb, you want the class intervals to each be equal width. So every class interval is just as wide as every other class interval. And the corresponding... Yes, Ed?
So the first problem we just solved. So can we term it as on group frequency distribution? Because they are on group.
Sorry, the group frequency distribution?
On group. Because we now group them up in the classes. So can we call them on group frequency distribution?
Yeah, I guess we can. Yeah, we could call it a group frequency distribution if you want to. Sure.
Okay, thank you.
Yeah. Okay, so this corresponding histogram should have 1 bar for each interval. Okay. And so what's an example? So I'm going to give you one example where the data is already given to you. So here, this is a survey, which I don't even know how many people were chosen, but this is the number of minutes used on a cell phone every month. So there were a number of people. This is back in 2008 also, so before cell phones were, as this is again in 2008, so people didn't use cell phones as much as they do now. These numbers seem a little bit low. So, so the frequency was people who used 0 to 200 minutes. That relative frequency was 0.585, so 58.5%. 200 to up to 400, that frequency was 180. 400 to up to 600, that frequency was 0.115, so 11.5%. And 600 to less than 800, that relative frequency was 0.120. So 12%. Notice that I have these. So why do I have these less than signs? Well, the idea is, well, if someone used exactly 200 minutes, what category do they belong in? And so what this says is that because instead of 0 to 200, we're saying 0 to less than 200, so it really means 0 to 199, that's saying that somebody who used 200 minutes unambiguously belongs to the second category. It's the 200 to 400. It's the 200 to less than 400 category. So in this case, it would be 200 to less than 400. I've also seen it where you can make the boundaries of the intervals like 0 to 199.5 and then 200.5 to 400. And this is not, I don't know, I feel like that makes the histogram look messy. I like this method where you just add this less than sign and then it makes clear if you're on the boundary, which category do you fall into? Okay. Daniel, question? Okay, so okay, so let's draw this histogram. I'm going to do this one using I'm going to draw this one using this website that that we had, this social science thing, and then the third example that we're going to do, I'll use Excel. Okay, so let's see, what do we have here? Okay, so let me stop my share here. So got it. Stop the share. Okay, so let me share my other screen here. Okay, so this is the website that was on one of the earlier slides. So this social science statistics descriptive histogram. Okay. Okay, so this is called a histogram maker. And so you need to put in your, oh, you know what? This is not, this one doesn't do so well for ranges. This one doesn't do so well for ranges. So maybe let's try Excel instead. Let's try Excel instead for this one. Okay, so we're going to do this one using Excel. So here's my Microsoft Excel. I'm going to fire up Microsoft Excel. Okay, so all right, so let's do home. I want it new, something new. Okay, so let me do something new. Okay, so what I have to do is I'm going to put in my frequency table. So I'll just recopy it for you over here. So I have my frequency table. And so for frequency table in Excel, what you do is you always put the maximum number in your table. So your maximum number in your table is going to be is going to be how you write the interval. So instead of 0 to 200, I'm going to write 199 because that's like the maximum number of minutes that falls into that category. And then I'm going to have 399, and then I'm going to have 599, and then I'm going to have 799. Okay, so this is the number of minutes, and this here is going to be the relative frequency. Okay, and so for the relative frequency here, what do we have? We had 0.585, 0.180, 0.115, and 0.120. Okay, and it's made some. Yes, I'm using Excel now. This is Excel. This is how to do it on Excel. Okay, and then the third example that we do, I'll use the website. So this version is Excel. The website is not very good for ranged stuff, or at least it's not good for this kind of frequency where you don't have discrete data. Okay, so what do I do then? So once I have this, I go to data up here. And data has this little tab up here that's called data analysis. Depending on your version of Excel, it might be a pull-down menu and it'll say data analysis. And so what I do is I highlight the table and I click on data analysis. Where is this? Click on data analysis, and it has all of these different analysis tools that you can do, and they all mean different things. But one of the things on the menu is histogram over here. So I'm going to write histogram. Oh, no, sorry. Cancel. Sorry. The point is, sorry, I got this wrong. I actually don't use Excel very much. I usually use these websites, so I need to start. So let me read. You don't go to data. For a histogram, if you want to do a data with histogram, you have to have a whole bunch of data. If you already have a frequency table, then for a histogram, you go to insert, and then you get this stuff with all of these little charts over here. And then this one here looks like a bar chart. So what you're actually going to do is going to make a bar chart from the data. So what I can do is make a 2D column graph here. What did I do? This is not right. What did I want to do here? Insert histogram. Okay, here we do. Okay, I want to do a histogram from this. Why am I not? This is not. This is not working the way it's supposed to. I have this relative frequency table already here. I should be able to just make column graph. This, I want to say here, blah, 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 blah. Sorry, let me take one more second and then maybe okay, you know what? For the time that we have, let me skip this for the moment. Can you remove the background screen? Then the real screen will be visible. So what is the not visible? Oh, okay. It's not showing on the screen. I am using Excel. Did I not do my share? Sorry. Sorry. Okay. Let me go back to the meeting anyway. Okay, sorry. You know what? I think I wanna prep the Excel a little bit better for next time, and it seems like it's not working that well anyway. So for now, let's actually skip the Excel. We'll do this next week. What I do want to do is do one version with the website. Maybe for next week we'll do the Excel nice and slowly in real time, so that everybody can learn a little bit more about Excel. I don't want to rush it, so let me instead just skip that example for now, and let's do one other example that I'll do on the website, and then we'll do the Excel next week. So I'm sorry about that. It seems like the technicalities with the screen display are not working so well. Okay. So let's try one more example that we'll use using the website. So suppose that we're not given a frequency table like what we had in the last example, but instead we're just given a list of data, like exam scores from a class. So there are still too many different scores for a discrete frequency table to be useful, right? If you have a class of 50 people, you might have 35 different scores on an exam, and most scores will be one person or two people or no people. And if you just draw a histogram with every category for every single possible score, you're usually just not going to get something that's very useful to look at. So instead, what we're going to do is use class intervals. And so the procedure is that we decide first on what class intervals to use, and then we build a frequency table using those intervals. And after we do this, we can draw or have a computer draw the histogram. Okay, but we have to choose what are the intervals to use. So one rule of thumb is for the number of intervals to be roughly the square root of the total number of observations. Again, this is not a hard and fast rule, but it often leads to useful histograms that give insight into the overall distribution of the data. Sometimes you may want to use more intervals, sometimes you want to use fewer intervals. And then remember we have the formula, not remember, but I'm saying we have a formula that relates the number of the intervals and the width of the intervals, that they're going to be related by this formula that the number of intervals times the width of the intervals is the range of the data. And the range of the data, remember, this means maximum minus the minimum. Okay, sorry. Oh, sorry. Oh, bring back the screen. Yes, sorry. Let me bring back the screen. Apologies for the technical issues. Okay, let's try this. Okay, sorry about that. Okay. So let me actually go back to what I was saying from the beginning. So suppose we're not given a frequency table and we're given a list of data instead. There's too many different scores for the table to be useful. So we decide on what class intervals to use, and then we build a frequency table using those intervals. Okay. So one rule of thumb is for the number of intervals to be roughly the square root of the total number of observations. And it's not a hard and fast rule, but it often leads to useful histograms that give insight into the overall distribution of the data. And we note that the number of intervals and the width of the intervals are related by this formula, that the number of intervals times the width of the intervals is equal to the range of the data. And that's the maximum measurement minus the minimum measurement. Okay, so example. So let's say that we have a class and they have the following scores on an exam. So 53, 56, 61, and so on up to 98. Okay, so the number of measurements here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So there's 30 measurements here. And so the square root of 30 is about 5. You could use 5 intervals, you could use 6 intervals, you know, we'll decide to use 5. Okay, so here we have 5 class intervals. What's going to be the width of each interval? Well, the width of each interval over here, we see that the width is going to be, if we divide by the number on both sides, we have that the width is equal to the range divided by the number of intervals. So in this case, our range is from 53 to 98. So it's going to be, so here we have range divided by the number of intervals. So our range is 98 minus 53, and our number of intervals is 5. And so that means, what do we have? We have 45 over 5, which is equal to 9. So the width of our intervals is going to be 9. Okay, and we're going to start them from the bottom of our range and go up to the top of our range. So when we're doing our frequency table, so we have interval, score interval, and frequency. So our first interval is going to be 53 to less than 62, because they're going to be all of length 9. Then 62 to less than 71. 71, maybe I'll write out the word 2 instead of using a dash. So 53 to less than 62, 62 to less than 71, 71 to less than 80, 80 to less than 89, and lastly 89 to, and in this case it's the last one, so we don't need to have a less than, right? We can just go all the way up to 98. Okay. Okay. And so what do we have here? Well, let's see. How many scores in the 53 to less than 62 range? We have 1, 2, 3. So the frequency here is 3. How many in the 62 to up to 71 range? We have 1, 2, 3, 4. So frequency here is 4. In the next range, we have 71 to 80 is 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. Then from 80 up to less than 89 is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there we have 9. And then from 89 to 98 is 1, 2, 3, 4, 5, 6. 6. Okay, so this is our frequency table. Okay. And so now, how do we make a histogram with these intervals? Well, let me now go to the website. And I'm gonna show you how to do this. So let me stop my share again. Stop share. Okay, so let me share my screen here, Google Chrome. Okay, let me move this. Can I move this? Move this bar somewhere. Okay, so can people see the histogram maker on this website? Can this be seen? Is that okay?
Yeah.
Okay, good. So what I'm going to do here is I'm just going to put in all of my data. So this is really nice. It just lets you enter all of your data. You can just enter each one on a new line. So 53, 56, 61, 62, 68, 68, 70, 72, 73, 73, 75, 77, 78, 78, 79, 80, 81, 84, 85, 86, 86, 87, 87, 87, 89, 90, 92, 92, 96, 98. Okay, so this was the data. Okay, so this was the data. All right, so now all that you do is you just click on generate, okay? And it's going to make a histogram, but it may not have the data that we want. So what it does is it automatically decides on classes for you. Let me try to make this a little bit bigger because I know the print is very small. So it automatically decides on classes, and it decided it was going to make its classes with size 8. So 53 to 60, 61 to 68, 69 to 76, and so on. And it was going to use that. Let me just try to zoom out now. Okay, and so it used those classes to make a histogram. And so see here, it has the x-axis labeled from 53 to 61, 61 to 69, and so on. It has one bar for each interval, and it has the heights of the bars with the relative frequencies, and it has and it labels each bar here. And it also gives us a whole bunch of other information. But now let's say that we decided we don't want 6 intervals, right? We want 5 intervals, right? So we want 5 intervals. The data is just the same data that I had on the sheet. I just put it in. It's from some real. I just made it up. But I mean, you can imagine running this with the exam scores of the students in your class. So now, what do we do? Well, we can edit. So it shows that the number of classes is 6. Let's say we wanted it with 5 classes instead. Okay, so we can switch to 5 and click on Edit Histogram. And now it's going to have this histogram, right? It's exactly what we wanted. But it's okay. But here, see, it's still not exactly our histogram because it's using 5 classes, but it's not having them run from 53 to 98. It's having them run from 53 to 102. So let's say instead that we wanted to actually specify the class range. So if I want the class range to be 9, over here its class ranges are 10, right? Each class contains 10 numbers because it's 53, then 63, then 73, and so on. But if I wanted to change the class range to be 9, then I can edit the histogram. And now finally, we have the histogram that actually corresponds to our data. Okay, so here we have 3, 4, 8, 9, and 5. I guess actually probably we would have a 6th class in this case for the single data thing, which is above 98. So the point is this website is very nice because it's pretty easy to use. You can just put in your data and then you can choose all of these things like the number of classes and the lowest class value, and you can specify the class range, and you can do all of these things and it will automatically give you a histogram. Now, Excel is a little bit harder, but it's also a little bit more powerful. There's more that you can do with it. So I think it's worth to teach about how to do this in Excel. It's worth it to probably reserve a lot of time to do that. So maybe the next time we meet, we'll spend a good amount of time doing Excel. So for now, let me just stop the share. But in the meantime, and let me share my screen again. Share content, screen. Okay, so we can do that histogram, and that website, by the way, if you want to get to it, it's here in the notes. It's here. It's this website over here. So if you have some data and you want to make a histogram over on the websites, then this is. I mean, there's lots of websites where you can do histograms, but this is one that you can do without really knowing how to use Excel. Okay, so next time I'll focus more about Excel, which is a little bit harder to use. So there's a little bit more stuff that you have to learn. So do that for Excel next time. But I will say for next time, so here's some homework. So the following is a frequency distribution for commuting times to work in minutes for working adults in a county in California. So these are the different amounts of time that it takes people to get to work from home. And so the question is to add a column to this table for the relative frequency, and then create a histogram for the data using relative frequency on the vertical axis. And this is probably small enough intervals that you can do it by hand if you want. And then homework exercise number 2 is we have following data that represents total length of roads in miles in various subdivisions in the US. And the data was used to help determine whether it makes sense to build power lines for current, to build them above ground or underground. That maybe depends on how much roads you have. And so it's a 2-part exercise. So first, construct a stem and leaf plot for this data using the thousands digit as a stem. And then construct a histogram for the data using these classes 0 to 1,000, 1,000 to 2,000, 2,000 to 3,000, and so on. And if you want to use Excel, that's great, but I'll teach more about how to do Excel. In fact, when we go over these homework exercises next time, I will solve them using Excel. So I'll show how we can do these in Excel the next time. But in the meantime, these questions are doable by hand. You don't need Excel to do these. And so then reminder is that there is no meeting next week, October 6th, because I'm going to be traveling that day. So the next meeting is actually on October 13th then, and it's going to be at 3:30 p.m. So it's 1 hour earlier than usual. I'll send a reminder about that. Note the time change. And at that meeting, we'll discuss cumulative frequency tables, plots and percentiles, and Excel. Okay, so we'll do a lot about Excel there. Okay, so sorry that the Excel demonstration didn't work today. I'll make sure that it's very well prepared for next time, and we'll be able to do that then. Okay, so I think that is it for today. Thank you very much for your attention. And as always, I'll send the recording and I'll send the notes later on today. Right, any questions?
Yes, sir. Yeah.
Yep.
Yeah, Prince.
Yes, Prince.
Yeah, thank you so much for the presentation today. And my question is June to the histogram what we're doing. But when you got the number, when you got the number after dividing the range, the weight will equal to the range and all what the number. Yeah. Actually, I wanted to know, how did you get the number? So it's just unto you that you select a number which you can be able to use, or how did the facting about?
Yeah. So you're just so I was using this rule of thumb that often where are we? Here we are. Yeah, so often a good number of intervals to use is the square root of the total number of observations if you're having some kind of small number of observations. So in this case, we had 30 observations. So we want to use some number that's close to the square root of 30. So we could use 5 or we could use 6. In general, it's kind of like the stem and leaf plots. There's no right answer. You just want the number that's going to make your histogram the most useful. So if your number is too big, then you just have very few entries in any category, and your histogram is just going to look like a little flat line, and that's not going to be useful. And if your number is too small, then everything's going to be in 1 or 2 categories, and you're not going to learn anything about the distribution. So one thing that you can do is experiment with using different numbers of intervals and see how different your histogram looks. And maybe there's one number that's going to be the most representative. But if you want a rule of thumb to choose the number, roughly you can try, as for the homework questions, for instance, roughly you can try the square root of the total number of observations. Pick a number that's near that square root, and you should get a nice looking distribution.
Okay.
But you can choose whatever you want. Yeah.
Okay. Thank you. So the next question is this.
Yeah.
Okay. Taking the minimum from the maximum, when it happens, if I get my result, can the result end to decimal? If I divide every other thing I got, can it end to decimal also?
Yeah, you can use decimal. And remember, it doesn't have to be the exact range of the data here. So this is, so for instance, for these data, the range is 98 minus 53, which is 45. But it's fine to have a histogram that goes a little bit bigger than the range of the data, right? So it'd be fine here to take the range if I wanted to say be 50 to 100. And then if I divided that into 5 intervals, each interval would have size 10. So you can always make the range a little bit bigger if you want to avoid decimals, right? Because this number always needs to be an integer, right? And so it's nice usually if the width is also an integer. So if you have the range of data and you're picking the number and you divide it and this width turns out not to be an integer, I mean, that's okay. But you could also just make the range a little bit bigger if you wanted to in order to make the width an integer. Okay, all of these things you can kind of choose however you want. It's all about just getting the best visualization. So there's no rule that the histogram exactly has to cover your range. It has to at least cover your range, but you can make the range a little bit bigger in the intervals, and that's going to be fine.
Okay. Thank you so much.
You're welcome. All right, other questions? Yeah. So by the way, if you have not yet put your name into the chat or written anything in the chat, please do so that we have a record that you were here. Okay. Sangay or Charles, anything you need to say?
Thank you for the day. We are still trying to work on our distribution of the data. Yeah, Mr. Brooklyn will speak more on it because he's trying to work on it. He has been calling people to confirm. If Mr. Brooklyn call anybody, please make sure you answer your phone or return your call so they can make sure you receive your data before the class time. He usually distributes the data on Thursdays. And those who don't get it on Friday, he sends it. So you will speak more to that. We pray to be more effective in the next class days. Thank you for everything.
All right, you're welcome.
Andrew?
Yes.
Yeah, thank you a whole lot. Yeah, the histogram, you can use discrete and continuous data to construct, a histogram.
Mm-hmm.
So what you did using the discrete, data host,
Mm-hmm.
I think one of the students asked, if you can use on group data, to construct a histogram. Yes, that can be done. What I want to say is that you see this data cards distribution is kind of challenging because from Thursday you will call, people phones will be off. Friday morning you call, midday you call, you can't get them. Just about to say, well,